Today we're going to be doing a complete setup tutorial for the Raspberry Pi 5 and the AI kit, which can help us do some object detection. However, instead of just set it up and show some basic examples, we're going to go one step further and actually give it some functionality so that when the camera does detect a person in the frame, it will actually go ahead and send a notification to our cell phone using a Telegram bot that a person has been detected. So we're going to hop right into it and set this up from the ground up. Before we get started with the actual physical install, there are a few prerequisites that I would like to make note of. One of those is you should have a micro SD card on hand. You need a Phillips head screwdriver, and while not necessary, it would be quite helpful to also have a spudger. Finally, having a Raspberry Pi camera with a cable that looks like this is going to be very helpful because that is what attaches to the Pi. If your camera has a cable that looks like this instead, it unfortunately is not going to work with this model of the Pi 5 as it will not fit in either of these camera connection slots. With that out of the way, we can essentially go ahead and begin the steps to install the actual AI hat onto the Pi. And for this, we can kind of move everything out of the way except what we see right here in the frame. And to go ahead and start, we're basically just going to take the Pi and flip it around and grab this little piece right here, which is kind of a GPIO header extension, if you will. Now, quick note, once you put this on, it is rather difficult to get off, so it's perhaps just something to make note of that this is a little bit difficult to actually take off once it's been placed on the Pi. So we just put it on like this, and once all the pins are lined up, we push down and make sure that it seats properly at the bottom. Can take a little bit of force, but once it's done, it will look something like that. Once you have this header extension on, you can go ahead and actually just place the AI hat over it and start to press down. However, to make things a bit simpler, I would actually recommend going ahead and just mounting these onto the base of the actual Raspberry Pi prior to fitting the AI hat. In order to do this, if your kit is like mine, it can be kind of confusing because there are two different screw lengths. Now, being that I got this kit used, I can't actually find the original instructions, but from when I've done this before, I noticed that if I put the long screws through the top of the hat down towards the base of the Pi, it works fine. So to start this, I am just going to go ahead and put the small screws through the bottom and hold them in. And what I like to do here is just kind of hold the screw in like this and then basically spin this little riser until it becomes tight enough to hold the screw and itself onto the Pi. And I will basically just repeat that for each corner, and then we can go ahead and move on to actually installing the hat. Now that all of these black risers are installed, as well as the GPIO header extender, we can basically go ahead and place the Pi down onto the ground and grab the AI hat. Now, for the AI hat, we want to make sure that we put it on the right way. So if you were actually to put this on upside down like this, you would just know because the green would be here and the holes for the PCIe and for the camera ports would not be in the correct spots. With that out of the way, we are basically just going to guide this on first by mating these pins into the holes right here. So you might have to kind of feel it out a bit. It is a bit harder for me right now because I'm trying to do it at a precarious angle, but once it is on like that, we can basically just go ahead and place the Pi back down and slide it until this gets a little tight and we are met with this contacting our 4 risers. Now, I want to quickly make note of one quick thing. For those of you who may be interested in mounting this into a 3D printed case, but you realize, hey, with these screws on the bottom, how do I use the mounting holes? If you actually get an M2 by 22 screw, which is a little something like this, it will actually go through these holes instead and come out of the bottom, assuming that the bottom screw is not placed in. And then you can actually use this to screw it into a 3D printed thing of some sort. With that out of the way, we are going to just go ahead and take the remaining 4 screws and go ahead and screw them in. And for this, it will just be beneficial to use the Phillips head. Don't over tighten them all right at once. So basically, you don't want to make any one corner as tight as it can get before all of the screws are in, as it could kind of tweak the layout or orientation of this hat. Now that all of the top screws are in, I'm just going to once again gently on each corner push down to make sure that this is properly seated on this extension header, and seeing that it is, I am going to go ahead and just tighten these a little bit more so that everything is nice and secure. And I'm going to flip it over to the bottom and do the same for the bottom screws. Once this is done, we do have one more step to actually make a physical connection between the AI hat and the actual Raspberry Pi, and that is to go ahead and install this small little PCIe extension cable. Now, there is a correct way to install this and there is an incorrect way to install this. So we want to make sure that the gold contacts here going into the top face towards the ceiling, and the gold contacts here that will go into the bottom port here are going to face towards the actual ports on the Pi. Now, this is where something like the spudger comes in handy, because if these are kind of locked into place like that, trying to get at them with your fingers can be a little difficult. So we can just usually use the spudger to go ahead and kind of just push them into position. So this one you push back, and the bottom one, as this, you basically just push up. Now, I find it a bit simpler to actually go ahead and put the bottom in first, because it just makes things perhaps a bit simpler because you have more leeway up there to actually fidget with it. So it is also possible, I suppose, to have done this prior to actually having installed the hat. I just didn't want to do that, as I don't want this cable to be at risk of getting pinched or anything like that. So once the cable is actually seated inside this, we are going to need to then go ahead and just push down on this clip. Now, these clips can be kind of a pain in the butt, because if you just push down on one side, it will just tighten that side. So having something a bit thicker or longer like this can help, because you can put more pressure along the entirety of the clip. However, you can just kind of go ahead and push it down like that. And I'm actually just going to use the side of this so I can get pressure on every area of the clip. And once we've done that, we make sure that the contacts are correct, being that we can't see them here, so they are facing the ports, which is good. And then we basically just go ahead and do the same up here and slide that in just like that. And it will seem like it's not actually fully in, because you will see this much of the gold contact still exposed. However, that is just how it is. It is properly in place. So we then just kind of pinch this together, and it is now properly installed. Being that we are going to actually use the camera as well, the final thing we need to do, as opposed to obviously just putting the SD card in, which I will show right after this, is go ahead and actually connect the camera cable. Now, the camera cable can be a bit tricky, and I do know this from having messed it up myself. So just as we had to take note of the gold contacts for this PCIe connector, we also need to do so for the camera. And kind of how it went in the bottom here, the gold contacts for the camera cable are going to be facing towards the ports of the Raspberry Pi. This is equipped with 2 camera slots. I am just going to use this one, as I just kind of feel like that one. And actually getting these pushed up, again, can be kind of a bit difficult. So if you just push up on one side of it, it's just going to make it kind of off kilter and can be kind of a pain. So you just kind of have to sneak something in there to get as much pressure as you can to get the whole thing up. Just feel it out. It is quite tactile, and you will likely be able to feel when it's right and when it's not right. So once that's done, we just basically take our camera cable and make sure that the gold contacts are going to be facing outwards or towards the ports, and we basically just slide it in from the top down. And it is a bit tight here because the AI hat is installed. I suppose you could do this prior to the installation of the AI hat. However, I don't do that because I don't like the idea of these cables getting pinched. And again, we just basically then need to push down on this, but on all sides at the same time. So that's when having a spudger or something like that helps. And we just lay it across and push it down. And we can see that this is now properly connected, and there is a bit of force there, so it will actually hold itself in. However, don't put too much strain on these cables. They are not hyper delicate, but just best not be kind of mangled around. That is essentially the completed install of the the AI hat, as well as a camera. The only other thing is, after the next step to install the micro SD, you are just going to go ahead and make sure that the gold contacts of the micro SD card are facing towards the actual circuit board of the Pi, so that the actual text on the SD card is facing out that way. So just like that. And that's going to go ahead and actually conclude the setup portion of this physical setup portion of this tutorial. Now that all of the hardware is set up for us to actually go about using the AI kit on the Pi, we do need to go ahead and just get an operating system flashed onto our micro SD card. Thankfully, the Raspberry Pi Foundation has a quite simple and nice to use tool to do this, which is called the Raspberry Pi Imager. In order to get this, we just go to raspberrypi.com and software, which is where we can go ahead and download this program. Being that I am on a Windows PC right now, I am just going to hit the download for Windows, and it will go ahead and download the exe to get this working. Once that's done, I am just going to open that, and I will now minimize out of the browser as we don't need to be in there anymore. And we are just going to go ahead and run through the installation steps for this, and you can see it is quite simple, and upon completion of that, we will just run it. Now, this is quite simple to use. For us, we just click Choose Device, and being that we are going to be using the Raspberry Pi 5, which is the first thing that shows up here, we can just select that. Following that, we want to choose our operating system, and for the purpose of this tutorial, I am just going to go ahead and choose the default one that it shows me, which is the Raspberry Pi OS 64-bit, released on November 19th of 2024, and it is the newest recommended desktop version of Raspberry Pi OS. So once we select that, we need to go ahead and choose storage, which is where we need to just go ahead and insert our micro SD card into the computer that we will be using to flash this card. Once that's inserted, we can go ahead and select Choose Storage, and it shows up right here as a 64 gig SD card. And once we have selected it, we hit Next. And right here is basically you can actually apply some customization settings. So essentially, you could pre-fill your user, your Wi-Fi network name and password, and things of that sort. For now, we're just going to not do that, and we'll just kind of ignore that for now. And we see, okay, it's going to erase the data on the card, and it basically just goes ahead and will install the operating system. Once it has completed writing and verifying, we will just get a little pop-up that it has been successfully written to the card, and we can just go ahead and then remove the card from our SD reader. Once the card is out, we just install it into the Pi the way we saw previously in the actual physical installation clip, and then we can go ahead and turn on the Pi. If this is your first time setting up the Raspberry Pi, you're going to want to make sure that you have a micro HDMI to HDMI adapter, which is what you can see here. There are two micro HDMI ports on the Pi, but for the purpose of what I normally do, I just use the one that is closest to the power cable. Following that, it is pretty easy to just plug in the peripherals as you would to any other computer. And finally, especially for the Pi 5 with the AI kit, you are going to want to make sure that you are using a genuine 27 watt 5 volt 5 amp power supply from Raspberry Pi ideally, or a rather decent quality third-party adapter could work as well. When the Pi starts up for the first time, it is just going to ask you to follow a few setup steps, such as making a username and password, setting your locale, and then connecting to a wireless network if you would like to do so. It will also ask you if you want to update the system at the current step, which I have skipped, and once that's done and you complete those steps, the Pi will restart and you will be met with your desktop background for the first time. Now that we have our freshly imaged SD card inserted into the Pi and it is booted up, we are just going to navigate directly to the Halo RPI5 examples GitHub. You can see the URL here, or you can search for the Raspberry Pi AI kit, and from the Raspberry Pi website there should be a link to the documentation here. Once we're on the GitHub, we are essentially going to scroll down until we see the Raspberry Pi 5 examples link. And if we click on that, we are going to want to actually just scroll down from where it brings us until we see the Halo Raspberry Pi 5 installation guide. And from this page, we can see that there are a few instructions pertaining to actually physically installing the AI hat on the Pi. But being that we have now already gone through and done that, we can go ahead and just kind of scroll down until we get to the update system line. Now, to make things simple, we are essentially just going to go ahead and kind of copy paste these commands into the terminal. Now, I do have a terminal window here open, so I am just going to start from the update system, as this is a freshly imaged SD card, but it doesn't mean that it's going to be the most up-to-date version of that operating system, even if you did go through the imager as we did. So we will run that, and it could take a little bit of time to go ahead and conclude. And it will prompt us, and we can just type Y and press enter to say yes, and it will go ahead and update the system. Now that our software has finished updating and we don't see any errors, we can go ahead and not run the fix broken install since everything seemed to have gone smoothly. The following thing we're going to do is scroll down and set our PCIe to Gen 3. So to do this, we are going to enter the Raspberry Pi config, which you can think of as more of a low-level kind of hardware configuration menu for the Raspberry Pi. From in here, we are going to scroll down to option 6 for advanced options. And when you are in here, you just use the arrow keys and the enter button to kind of navigate around this menu. And once we're in there, we scroll down to option A8 and press enter once again, and we press yes. So to do this, we will just use the left arrow key to go over to yes. And once there, we press enter, which will enable PCIe Gen 3. And it will give us a little message, and we just click OK. And to get out of here, if you just try to scroll down to actually go to finish, you won't actually be able to get there with just the down arrow key. So wherever you are here, you can just hit the right arrow key, and it will bring you down to that lower menu where you can then go ahead and actually exit out of here. So we have now done that, which will prompt us to reboot the system, and we can go ahead and press yes. Once the Pi has rebooted, we are just going to once again open up a terminal window, which you can quickly do using the keyboard shortcut of Control Alt and T. And once that's done, we are just going to, since I was following the instructions from the actual Raspberry Pi itself, I will just need to go back and open up the web browser, and in my history, I should be able to easily navigate back to the page I was at previously, which is right here. Now, for some reason, this terminal window seems to be a bit bigger than I recall it being when I restarted. And we're now ready to continue from where we left off, which was changing the PCIe to Gen 3. So we have done that, and we rebooted. So our next step is going to be to install the Halo software. And all we're going to do for this is just copy paste this command into the terminal, and this will likely take a little bit of time, especially dependent upon network speed. So once we press Y to allow it to go ahead and install the software, we wait for this to conclude, and then following the conclusion of the software being installed, we will once again reboot the Pi. And once the Halo software has completed installing, we are just going to reboot the Pi by typing sudo reboot, which will go ahead and once again reboot the system. Now that the system has been updated and the Halo software has been installed, there are a few steps we need to follow just to verify that the accelerator is actually recognized by the system. The first of those is to simply copy paste this into terminal in order to verify the physical installation and accessibility of the chip. And assuming everything is okay, you will see a sample output like what is shown here in the GitHub, which we do also see right here. So the board name is the Halo 8, and everything seems all right on that front. Following that, we are going to test the Tapas Core installation, which you can just think of as a kind of software framework that helps allow some of this image pipeline to work and things of that sort. Don't quote me on that, but I do believe that is relatively correct. And we can see here that, assuming everything is all right, we will see something similar to here. And because my terminal is so zoomed in, I actually can just go ahead and use the arrow key to scroll down until all of these are finished. And once we get to the last one of here, we will see end. And to get back to our actual terminal shell command, we can press Q on the keyboard, which will allow us to enter the following command, which is to check the Halo RT inference GStreamer element. So we copy this and paste it in. And as we did before, assuming everything works properly, we can cross-reference it with the expected result here, and everything does look good for me. No errors, so I will just go ahead and move on from there. Being that everything is okay, we can just continue following along with the steps here, which, as is hyperlinked here, allows us to just continue installing the examples. Now, when we click that, it does kind of bring you to a somewhat confusing page because you don't necessarily know where to actually go from here. So for the purpose of what we're going to do here, I am just actually going to click on this basic-pipelines.md here in the left-hand pane, and this will essentially bring us to the location we need to be to follow along to get our first example running. I am going to type clear in the terminal, which will just clean up all of the old output so that we have a little more space to look at and read. And to begin, we are simply just going to go ahead and clone this repository. Now, what this will do is essentially copy everything that is listed on this GitHub to our local Pi so that we can actually go ahead and use some of these scripts on our local machine. And we can see that did occur rather quickly. So once we're cloned and everything is all right, we do cd into the newly cloned repository, which just puts us in the correct folder to actually be able to work with some of this. And you will see me clearing my terminal more here just so we can actually continue to see the new messages. Once we're in here, we are just going to run the installation script in order to automate the install process, which can take a little bit of time. Once the quick installation has completed, we can see that we can go ahead and skip the 1 through 4 of the manual installation steps, being that we did do the quick installation. From there, if we scroll down a little more, we basically see that we can jump right into our first detection example. In order to run this, it is truly quite simple. The first thing we just need to do is make sure that the environment setup is sourced. So if we type this in here, we will see that it changes. So instead of just having this as my initial prompt in the terminal, we have this preceding it, which lets us know that our virtual environment is set up correctly and we should be good to go in actually running one of these examples. To jump right into that, we are just going to copy this, paste it in here, and we will be met with our first kind of experience of how this is working. Now, it does look identical to the demo here. However, the difference is it is running locally on the AI accelerator here. And we can see that it is drawing these bounding boxes, the labels, and the actual percent estimation of how sure it is that any of these labels are correctly identifying the object in the frame, if you will. Convoluted way to say that it's telling us what it thinks these are and how certain it is about that. Now, this is cool, but I feel like a lot of us may want to do something more kind of hands-on that relates to ourselves or our own environment. So for that, we just make sure we're clicked into the terminal. So meaning that you click on the terminal window. And if you have done that, you can type Control-C, which will go ahead and actually end that example. Now, for the fun part, which is to actually use this with our attached Raspberry Pi camera, we can simply scroll down a little bit and click on the running with different input sources link. And the first thing we see here is to actually go ahead and do that, but with our Raspberry Pi camera input. So all we do is run that script again, but with a flag to specify that we are using our Raspberry Pi's camera. And once we paste and enter, we will actually see the output of our camera, which for my thing right here is basically just a hyper zoomed in Bamboo A1 mini extruder. It does think the painting on the wall that is blurry and out of focus is a TV. And if I am to just kind of like snake my hand around here, it will say, okay, that is very likely a person, and etc. So this is quite cool and a first kind of look at how this actually works. However, for the purpose of this video, I want to go a bit further and actually kind of modify this to do something useful for us. Now that the demonstration examples are working fine with our Pi, we are going to go ahead and actually set up a Telegram bot that will send us a notification when the Raspberry Pi's AI camera detects a person in the frame. Now, in order to do this, there are going to be a couple of prerequisites that I am not going to show how to actually go about doing. The first of those is going to be to have a Telegram account, likely on your phone. It is quite easy to set up, and I can't show it because it would just contain too much personal information like phone number, things like that. But it is quite simple to set up, and it is perhaps likely you already do have Telegram. So with that out of the way, we are essentially just going to go back into the correct environment and location of these demonstration scripts so that we can go ahead and actually modify one of them to work with our new Telegram bot. The first thing we're going to do is just essentially make sure that we go back to the actual directory of the Halo examples, And following that, we are going to remember that as this is required for each new terminal session, we are going to just once again activate the virtual environment, just like that. And I'm going to clear out of there. Now, following this, there is going to be a Python package that we are going to need to download and install, and that is the Pi Telegram Bot API. Now, this will essentially allow us to simply integrate the Telegram bot control functionality into one of these scripts. So we type that into terminal, we enter it, and I have already installed it here. However, if you have not, it will just go ahead and install that into your environment. Now, the next thing we are going to do involves being on Telegram. Now, it will most likely be you doing this on your phone, but because I can't really easily record the phone screen and make it look good, I am just going to be using Telegram from the web in this case. So for that, I'm just going to search web Telegram. I definitely searched that wrong. But when I click here, and I am already signed in, so everything is fine, and we can go ahead and just kind of pretend that this is your Telegram phone screen. So the first step is to actually start a chat with the bot father, which I know it is a funny name, but it is going to actually allow us to make a new bot, which will be what notifies us if the person is detected in the image frame on the AI object detection script. So we type /newbot. Okay, make sure caps lock is not on like mine was. And we can see it autofills. So this is going to basically allow us to create a new bot. And we need to just give it a name, so I'll call it Notif bot. So, because it's a notification bot. And then we need to choose a username. A lot of them are taken, so, and it also needs to end in bot. So, okay, so like I said, a lot are taken. All right. And once that's done, we see a little message here with some pertinent information. And I do quickly want to note that this access token should not be shared. I am showing it for this purpose in the video as a demonstration, as I am just going to go ahead and get rid of this bot following this video. So I am not super concerned with the security ramifications of this. So from here, we are actually going to need to do one thing, which may seem odd at first, but will make sense in a second. We are just going to click this link, and again, pretend we are on our actual cell phone here, and it will pretty much look the same, just I'm on the web browser instead. And I am going to start a conversation with the bot by clicking start, which will send the start command. And all we are going to do right here is just send a couple of messages, which may seem weird. And remember, it's not like a ChatGPT thing, so don't actually expect it to respond to you right now. Following this, and after those messages are sent, we are actually going to need to go ahead and copy this access token. Once the access token has been copied, we actually need to go to the following address, api.telegram.org/bot, and then right here after bot, we are going to paste in the access token. So just paste that in directly after bot, and then following that /get updates with a capital U. And if I press enter here, we are going to see some JSON output that will contain something like this, which says, okay, true result. Unfortunately, that does not contain what we need from here, which is a chat ID. So I am just going to send it a couple more messages. And once I have done that, I am going to go back here and refresh the page. And we see that our messages have come in, and we just see our name and things like that. So what we are looking for right here is this chat ID number, excuse me, which you can see right here. So ours is just like this. And essentially from here, we are just going to copy, paste this, and save it into a text file. And we're also going to need to do that same thing with the actual access token as well. Now, I am just going to use a text editor through terminal here because it's simpler, but just save it anywhere. And we can see that is our chat ID. And then we are also going to save our access token. And then I will save this. And now I have that saved on my local machine. And for the purpose of what I'm doing here, I can actually go ahead and just kind of close out of all this, as the Telegram setup of the bot is actually pretty much complete. Now that the Telegram bot setup has completed, we are just going to go ahead and quickly outline the changes we're going to be making to allow it to send us a notification when this camera detects a person. Truly, I am just going to make this as simple as possible, but I would like to also quickly outline the code changes so that it just provides a little bit of context as to how this is actually working. Now, I am going into the actual file manager on the Pi here, as it makes things a little easier just to visually follow along with. And from within beneath our home folder here in the left-hand pane, we can see that we have the Halo Raspberry Pi 5 examples, which were downloaded to our machine when we ran the git clone in the earlier setup steps for the tutorial. From within here, we are going to click on the basic pipelines, and we can just focus our attention on this detection script, which is the script that we are actually going to be modifying to be able to implement our Telegram functionality. Now, basically, this is rather simple, but I do want to just, like I said, give a quick overview of it. So I'm going to right click on this, and being that I am on the Raspberry Pi, we don't have any real fancy code editors installed. So I am just going to open this with Thonny, which, as we can see by the tooltip, is a Python IDE for beginners. And we can see it is a relatively simple script, I think about 83 lines long, so nothing really too intimidating for someone to perhaps read through. Now, as we're not going to just be copying what I type into this, that would just kind of make it a pain. I will put the modified script up somewhere, so you can ideally just download it and actually replace the contents of this script with the demo script, and it should work fine. But we are going to take a quick peek at it. So I have the demo script here, and I am just going to go ahead and open that in Thonny as well, which will open it in a nice little new tab, which is kind of cool to see. And we can see that things are relatively similar here. However, there are a few slight changes that we will just quickly go over real quick. The first two are that we have now imported the time module as well as the telebot module, which is the Python package we had installed previously for the Telegram bot API to work. And once we go down here, we can see that in the original script, it is just really quite simple. And in the demo script here, we can see that we do have the Telegram configuration parameters, and one of those is the access token, and the other one is the chat ID. Now, if you recall, we have actually saved those to a text file, and we are actually going to need to go ahead and actually save those to get the script to work. So I am just going to open that text file once more, and the chat ID is the first number here, or the shorter of the two. And we are just going to go ahead and paste that within the two tick marks and make sure that everything went well, which it did. The next thing we're going to do is just do the exact same thing for the access token. So we copy and paste it in here between the tick marks. And then we notice a couple other things. So first we save that, but once we have gone ahead and saved that, we are going to see that we have a notification time value as well as a cooldown seconds value. So if we scroll down a little more, we can see that instead of just ending with this demo new function here that they have provided to kind of just guide you in something like this, we have a send notification function. And to put it as simply as possible, essentially, if the frame sees a person, it will trigger the bot to send a notification, which we can see right here, which is an alert emoji, which this is not showing, and then person detected. Now, in order to prevent spam, as this looks at frames very quickly, so essentially if my hand was in the frame in front of the camera for a few seconds, it would spam me with text messages. So we have implemented this little kind of cooldown thing where basically if it has already detected a person within the previous 30 seconds, it will not trigger the notification again until a 30-second cooldown period has been completed. Essentially, really, I think the easiest way to kind of show this is to just scroll down a little more and show you the only other place that we have actually modified this script. So if I go back into the original script, we can scroll down here and see that they already have something, an if statement for if a person is detected based on what the label says. So we can scroll down to our modified demo script into that same area, and we do see right here, if the label is person, we are simply going to call our function with the notification to go ahead and actually trigger the Telegram bot alert. Now that we have a simple understanding of how these changes work, we are just going to go ahead and test the script. Now, I had mentioned that you could just copy paste the changes into the original detection script, but that is kind of messy. So all I'm going to do is actually just copy this entire script, and I'm going to paste it into the basic pipelines directory under the Raspberry Pi 5 examples. And in doing that, it will be simple to run because all we have to do is change the original demo that we ran, which is the basic pipelines detection.py with the Raspberry Pi camera input flag. And all we're going to do is just change this to say demo script or whatever the script is named on your local machine. And once I run this, it will go ahead and open the camera object detection thing. However, it will be using our modified script with the Telegram implementation. So I don't really know how much I have working here, so I'm just going to keep this open so that hopefully we will be able to see it. And I don't know how loud the notification is. That's what I meant to say. But as soon as I put my hand here in front of the camera frame, we should see a notification. And it is probably kind of hard to see, but it did show up there and it says person detected. I don't know why the notifications are so quiet on this phone. I'm not really a big Android fan, so that may be why. And if I do it again right now, you'll see that it has been within that 30-second cooldown period, so it is not going to send it again. However, if I kind of just keep speaking verbosely for a few more seconds, it will have surpassed the 30-second cooldown period, meaning that if a person is shown up in the frame once more, it will actually go ahead and resend the alert. So I should probably be getting close to the time where that would happen. And we can see that just like that. Oh, the screen went black. The person detected has showed up once more. So quite simple. However, I did want to just give a sort of actual functional use case for a tutorial instead of just kind of showing it. And you run something like this and you think, okay, this is quite cool, but what do I actually do with it? So that's kind of what I like to do, is actually give some more functional usability to some cool technologies like this object detection and things like that. And it has been within 30 seconds, so it won't show up right there. But that is really likely going to conclude this video. I hope it was helpful and not too verbose. I had kind of gone back and forth about showing this from its entirety, from actually physically installing the AI kit, being that this has been out for a while, but I want it to be consistent and have some continuity, so I figured I would just do a full tutorial and then kind of add in the Telegram thing as well, as it's kind of cool. So that's pretty much going to sum it up, and thanks for watching.